Our solar system is a place of wonder. It's filled with a diverse cast of planets. Among them are the ice giants, Uranus and Neptune. These distant worlds located beyond Saturn are shrouded in mystery. They offer a unique glimpse into the outer reaches of our solar system. Uranus, the seventh planet from the Sun, is an icy blue giant. It's known for its extreme tilt and faint rings. Neptune, the eighth and farthest planet, is a deep blue world. It's famous for its powerful storms and intriguing moon Triton. These planets are much smaller than Jupiter and Saturn, but they still dwarf the inner rocky planets. Their composition and characteristics set them apart. They provide valuable insights into the formation and evolution of planetary systems. Uranus and Neptune are often called ice giants to distinguish them from the gas giants Jupiter and Saturn. This distinction arises from their composition. While gas giants are primarily composed of hydrogen and helium, ice giants contain a higher proportion of heavier elements. These elements include water, methane, and ammonia. They exist in ice form in the planet's cold interiors. This difference in composition has significant implications for the planet's structure, atmospheres, and overall evolution. The presence of ices gives Uranus and Neptune their distinctive blue hues. It influences their internal heat flow and magnetic field generation. Understanding these differences is crucial to unraveling the mysteries of these icy worlds. Uranus is a planet of extremes, a world that defies the norms of our solar system. Its most striking feature is its extreme axial tilt, which is unlike any other planet in our solar system. Uranus is tilted on its side, with its rotational axis nearly parallel to its orbital plane, making it appear as if it's rolling around the Sun. This unique orientation means that Uranus essentially spins on its side as it orbits the Sun, creating a bizarre and fascinating dynamic. This unusual tilt has dramatic consequences for Uranus's seasons, leading to extreme variations that are unlike anything we experience on Earth. Each pole experiences decades of continuous sunlight followed by decades of darkness, creating long, harsh seasons. This extreme seasonal variation creates unusual weather patterns and atmospheric dynamics on Uranus, with storms and winds that can be quite intense. Uranus is also home to a faint ring system which adds to its unique and mysterious allure. It's much less prominent than Saturn's rings, but still an intriguing feature of this distant planet. The rings are made up of dark, icy particles which reflect very little light, making them difficult to observe. These particles range in size from small grains to larger boulders, creating a complex and varied ring system. Uranus has numerous moons, some of which interact with its rings, adding another layer of complexity to this fascinating planet. Neptune, the farthest planet from the Sun, is a world of intense storms and deep blue hues. This distant giant is a captivating blend of mystery and power, swirling with dynamic weather patterns that are both beautiful and terrifying. Its atmosphere is a turbulent mix of hydrogen, helium, and methane. These gases create a thick, hazy layer that envelops the planet, contributing to its striking appearance. The methane gives Neptune its distinctive blue color. This vivid hue is a result of methane absorbing red light and reflecting blue light, making Neptune stand out in the vastness of space. It also creates the conditions for powerful storms to form. These storms can rage for years, with winds reaching incredible speeds, showcasing the raw power of Neptune's atmosphere. Neptune's most famous storm is the Great Dark Spot. This colossal storm system is a testament to the planet's volatile nature, with its dark swirling clouds dominating the landscape. It was first observed by Voyager 2 in 1989. The spacecraft's flyby provided humanity with its first close-up view of this distant world, revealing its secrets and sparking our imagination. The Great Dark Spot is a massive storm system that's similar in size to Jupiter's Great Red Spot. Both storms are immense, but Neptune's is unique in its own right, with its own set of characteristics and behaviors. Neptune also experiences supersonic winds. These winds are not just fast, they are among the most extreme in the solar system, reaching speeds that defy comprehension. These winds are among the fastest in the solar system. They can travel at speeds of up to 1,200 miles per hour, making Neptune a planet of extremes. They whip around the planet at incredible speeds. This relentless motion creates a dynamic and ever-changing environment where the weather is always in flux. Neptune's largest moon, Triton, is a fascinating world in its own right. Triton is a cold, icy moon with a surface covered in frozen nitrogen, making it one of the most intriguing objects in the solar system. Triton is unusual because it orbits Neptune in the opposite direction of Neptune's rotation. This retrograde orbit is a rare phenomenon and suggests a complex history. This retrograde orbit suggests that Triton may be a captured object. Scientists believe that Triton was once a free-floating body in the Kuiper Belt before being captured by Neptune's gravity. It was once a dwarf planet or Kuiper Belt object. This origin story adds to the mystery and allure of Triton, making it a key piece in the puzzle of our solar system's history. Section 5. Inside the ice giants, a glimpse into their hearts. While we can observe the outer atmospheres of Uranus and Neptune, their internal structures remain hidden from direct view. These distant, icy giants hold many secrets beneath their thick, gaseous exteriors. However, scientists have used a combination of observational data and theoretical models to piece together a picture of what lies beneath the clouds. By studying the gravitational fields, magnetic fields, and atmospheric compositions, researchers can infer the internal makeup of these enigmatic planets. Both Uranus and Neptune are believed to have similar internal structures. Despite their differences in appearance and atmospheric conditions, their cores and mantles share many characteristics. They consist of a rocky core surrounded by a thick mantle of water, methane, and ammonia ices. This composition is quite different from the gas giants Jupiter and Saturn, which are primarily made of hydrogen and helium. This icy mantle is not in a solid state, however. Instead, it exists in a supercritical fluid state, where the distinctions between liquid and gas phases disappear. It's thought to be more like a hot, dense fluid. This fluid is under immense pressure and temperature, creating conditions that are extreme and unlike anything we experience on Earth. The extreme pressure and temperature conditions deep within these planets create exotic states of matter. These states include superionic water, where water molecules break apart and the ions move freely, conducting electricity. These states are unlike anything found on Earth. The unique conditions within Uranus and Neptune provide a natural laboratory for studying these exotic forms of matter. The internal heat flow and magnetic fields of Uranus and Neptune are also intriguing. Unlike Earth, where heat is primarily generated from radioactive decay, these planets have other sources of internal heat. Both planets generate more heat than they receive from the Sun. This excess heat suggests that they have internal heat sources, possibly from the slow contraction of the planets or from the differentiation of materials within their interiors. This suggests that they have internal heat sources. The exact mechanisms are still a topic of research, but they play a crucial role in the planet's dynamics and evolution. Their magnetic fields are also unusual. Unlike Earth's relatively stable magnetic field, the fields of Uranus and Neptune are highly tilted and offset from their rotational axes. They're tilted at significant angles to their rotational axes. This unusual alignment suggests that the magnetic fields are generated in a different manner compared to Earth. These magnetic fields are offset from the planet's centers. This offset indicates that the dynamo processes generating the fields occur in a shell outside the core, rather than in the core itself. This suggests complex dynamo processes at work within their interiors. Understanding these processes can provide insights into the magnetic fields of other planets and even exoplanets. Section 6. Voyager 2's Legacy: Unlocking Secrets. Our understanding of Uranus and Neptune was revolutionized by the Voyager 2 spacecraft. Voyager 2 flew past Uranus in 1986 and Neptune in 1989. These flybys provided our first close-up views of these distant worlds. They revealed a wealth of information about their atmospheres, rings, and moons. Voyager 2's observations revealed the intricate details of Uranus's rings. They discovered new moons orbiting both planets. They also provided the first insights into the composition and dynamics of their atmospheres. The data collected by Voyager 2 continues to be analyzed today. It provides valuable clues about the formation and evolution of these ice giants. Section 7. Future Missions: Pushing the Boundaries of Exploration. While Voyager 2's flybys were groundbreaking, they only scratched the surface of what there is to learn about Uranus and Neptune. Scientists are eager to send new missions to these icy worlds to delve deeper into their mysteries. Proposed future missions include orbiters and probes. They could study their atmospheres, magnetic fields, and internal structures in greater detail. A dedicated mission to Uranus or Neptune could provide unprecedented insights into these enigmatic worlds. It could help us to understand their place in the broader context of our solar system. Section 8. The significance of ice giants. Understanding our cosmic neighborhood. Studying ice giants like Uranus and Neptune is not merely an exercise in satisfying our curiosity about distant worlds. It also has profound implications for our understanding of planetary formation, the evolution of our solar system, and the search for life beyond Earth. Ice giants are believed to be common in the universe. Studying our own ice giants provides valuable insights into the characteristics and potential habitability of similar planets orbiting other stars. Furthermore, understanding the processes that led to the formation and evolution of Uranus and Neptune can shed light on the early history of our solar system and the conditions that gave rise to the planets we see today. Section 9. Conclusion. Uncharted territories. Uranus and Neptune, the icy giants of our solar system, remain enigmatic worlds full of mystery and wonder. Their unique characteristics challenge our understanding of planetary formation and evolution. They beckon us to explore further into the outer reaches of our cosmic neighborhood. As we continue to explore these distant worlds, we can look forward to new discoveries that will deepen our appreciation for the diversity and complexity of the universe we inhabit. The journey to understand these icy giants is far from over. It promises to be an exciting adventure full of unexpected twists and turns.